In this video, I'm going to show you a real-life experiment that my friend and I conducted, and from this experiment, you'll learn all the steps of doing a statistical inference test, and you'll also learn how to analyze the results of it. So first, I'm going to show you what our statistical question was, and then I'm going to go over how we carried out the experiment. After that, I'm going to state our null and alternate hypothesis, followed by the raw data and some visuals. And finally, I'm going to show you our final conclusion, along with some problems that we encountered when we ran this experiment. And the final results were pretty surprising, so make sure to stick around to the end if you want to see what they were. So the question that we asked ourselves was, does the data provide convincing evidence that slice serves on average have a greater number of serves that go in than flat serves? And we asked this because the serve is the most important shot in tennis, and the more likely that you get your serve in, the more likely that you're gonna win the match. So now my friend's gonna talk about what our procedure was to get the data.
For our procedure, we assigned a unique number to everyone on the boys' tennis roster. And then using a random number generator, we selected 15 numbers and made sure to ignore repeated values. These 15 numbers represented the 15 people for the match paired experiment. However, before we conducted the experiment, we let everyone hit 10 serves as a warm-up. We then flipped the coin to decide whether each subject would hit a slice or a flat serve first. If the coin landed on heads, then the player would do 3 sets of 5 flat serves first, and then 3 sets of 5 slice serves. If the coin landed on tails, the player would do 3 sets of 5 slice first, and then 3 sets of 5 flat serves. We then took the average number of serves that went in for all 3 sets of flat serves and all 3 sets of slice serves. We chose to do a one-sample t-test for paired data because each player in the experiment was a part of both treatments.
Now, before I show you the actual data, here's what our null and alternative hypothesis were. The null was that mu was equal to 0, and the alternative hypothesis was that mu was greater than 0. And we let mu equal to the true mean difference of the slice serves minus the flat serves that go in. So in other words, the null hypothesis is saying that the true mean number of slice serves is equal to the true mean number of flat serves that go in. And the alternative hypothesis is saying that the true mean number of slice serves is greater than the true mean number of flat serves that go in. So here's our raw data. The first table shows the number of slice serves that each player got in, along with the average over all 3 sets. And the next table shows the same thing, but with flat serves. And the last table shows the average number of slice serves minus the average number of flat serves that go in for each of the 15 players. And now I created a histogram on these numbers, and looking at it, it seems to be approximately normal without any extreme skewness or outliers. Okay, so now that we gathered all the data, we have to analyze the results. So the test that we did was the one sample t-test for paired data, and our degrees of freedom was equal to the number of players minus 1. So in this case, that was 15 minus 1, which is 14. And we also checked if the conditions for this inference test were met. And the first condition was the random condition, and in our case, the treatments, which were the slice and the flat serves, were randomly assigned to each player. And we didn't need to check the second condition, which was the 10% condition for independence, because this was an experiment. And the third condition was the normality condition, and based on the histogram that I showed you before, the sample data was approximately normal without any extreme skewness or outliers. And since these conditions were met, we did some calculations to find out what our p-value was before we decided to reject a null or fail to reject a null. So the standard error was equal to the sample standard deviation divided by the square root of the number of players in the experiment. In this case, the sample standard deviation was about 1.405, and the number of players in the experiment was 15, which gave us a standard error of about 0.363. Now to calculate our t-statistic, we did the sample mean, which was about 0.689, minus the value from our null hypothesis, which was 0. All of that divided by the standard error, and this gave us a value about 1.898. And this t-value corresponded to a p-value of about 0.039. And now we are ready for the final conclusion.
Because the p-value of about 0.039 is less than our significance level of 0.05, we reject the null. This means that we do have enough sufficient evidence that the average mean number of slice serves that go in is greater than the mean number of flat serves that go in, meaning that it is better to hit slice serves than flat serves. I'm going to now talk about what problems we encountered while running this experiment. The first problem was that some of the balls were at different levels of usability, meaning that some of them had less air than others. The second problem was that some people did not have their own rackets and had to use the rackets that we provided. This could impact the number of serves that went in because the player may not be used to hitting serves with a racket that isn't their own. Another problem was that all the players in our experiment had different skill levels. This means that it could have been the skill level that affected the number of serves that went in and not the type of serve.
So that's basically the whole rundown of our experiment. Let me know in the comments down below whether you agree with the final conclusion that we came up with. And thank you guys so much for watching all the way to the end. If you want to see more tennis related content, click on this video where I go over my predictions of the French Open tournament, which is happening right now, and I hope to see you there.